Hey guys and girls, welcome to my new course on image convolutions. In this topic, we are going to learn about image convolution. So, what's an image convolution? It's a very powerful technique using which you can manipulate images to achieve effects such as blurring the image or blurring the background of the image. You can have more kind of a depth perception, that you can manipulate the image so that you can see the depth more vividly using this technique. We can also use this image uh, to detect the edges in the images. We can also use this technique to detect the outlines in the images. And you can definitely use this technique for sharpening the images. So this has a lot of powerful application in convolutional neural network. If you That's a technique which is using machine learning to detect the objects in the images, to detect the buildings, to detect the animals. So basically the way that's achieved is you first identify basic parameter or basic things in the image such as edges, outlines, and using that technique you can combine more uh, convolutions to identify the bigger objects, right? So it's a very powerful technique, and we will go through examples as well as on code on how to actually achieve this using, and we will deal with few famous convolution techniques uh, in this entire course. So here is an example of an Pittsburgh skyline image. I'm using grayscale so that I can explain you convolution impact more clearly using grayscale images. So we want to remove complexity of color images at this point. So to human being, this image is an image of a beautiful downtown Pittsburgh, right? And you can see the aesthetics in the image. You can appreciate the bridge, the water, the buildings, and the uh, green trees surroundings, the whole thing, right? But what about a computer? A computer sees this image as nothing but just bunch of pixels, right? So basically, when you read the image using libraries such as OpenCV2, you can basically computer looks at is just an image with pixel intensity. Like if this is an 600 by 600 image, our computer will see as a 600 by 600 a matrix with rows and with 600 rows and 600 columns, and each cell value is nothing but the pixel intensity ranging from 0 to 255. That's all the computer sees it, right? So what's a convolution then? A convolution is a technique whereby you take a small matrix, so let's say 3 by 3 matrix, and then convolve it with the original image. Basically that technique, basically what it means is you slide this image, you slide this kernel on top of the original image starting at the top right, then multiply each value in the original image intensity with the kernel value. For example, 100 will get multiplied with 1, 172 will get multiplied with -1, 255 will get multiplied with 0, and you do similar things for other cells. So you start with top left, and then you slide the, and you either average or sum the final values, right? And then you slide this kernel from top left all the way to the right, and then again once those operations are done, you slide it to the bottom, and you repeat this operation until you convolve the kernel along the entire image. So here is few example, like you take the uh, kernel, first apply to the top left, right, and then multiply and average, then you uh, move it to the right. So this is what happens, right? This is for the just first 3 rows and columns of the original image. Then you repeat the process, so you slide to the right, then you further to the side and repeat the whole operation, then you slide down like this, and then you again slide down until you finish the whole matrix. So that's basically the convolution operation is. So why do we use it? So I would like to give you a few examples of how this technique is powerful.